Hello guys, hello everyone. This is a video lecture on data visualization which will contain 6 parts in 2 videos. First, we will try to define what data visualization is. Then we will take a look at data visualization as part of both the scientific and the business processes. Third, we shall discuss the modern goals of data visualization before proceeding with pointers for effective visualization. I then would present a few templates for visualization that stood the test of time before we finally jump into coding in Google Sheets and Python. At the end of this 2-video lecture, I will leave you with a sample dataset upon which you will practice or you may practice your data visualization techniques. So let us get started. What is data visualization? Data visualization is defined simply as graphical representation of data. When we turn data into its graphical form, we are visualizing. And if you ask, why do we need to represent data in terms of images? Why can't we just say them with words? I mean, words are easier to type and communicate. Well, apparently we want information to be in image form because of something called the picture superiority effect. That's just a fancy way of saying pictures are more likely to be remembered and understood than words. This phenomenon is a combination of 3 theories, namely dual coding theory, sensory semantic theory, and transfer processing theory, but we won't get into too much detail with that. For the purpose of the SEM, it just matters that you know why we are doing all this work to turn our data into images. Right now, it seems that visualization is always connected to big data. However, this is not the case. It is possible to visualize information even if they are not big or do not come in table and row format. Examples of this are health bars in games, signal strength of your Wi-Fi, and how much battery you have left on your phone. All of these visualizations are based on one singular value that's changing. So data visualization as part of the scientific and business process. It is also important to note that data visualization has evolved to become part of the scientific process, or in business terms, research and development. In order to arrive at new knowledge or a decision, we first ask an interesting question. That's step 1. Then in order to answer the question, we collect data, step 2. We then explore what we can do with that data. And then we come to model. We try to model that data we've collected. And then finally, we communicate the results. In these steps, data visualization may happen in 2 parts here. Exploring data means creating plots so we can understand what we have gathered better. And communicating data to an audience would mean crafting visualizations as well. Modern goals of data visualization. Currently, data visualization has 2 primary goals. First is exploratory. You want to explore what is happening so you can decide what to do. A cute and easy example of this is habit tracking using bullet journals. My source is Instagram because bullet journal enthusiasts seem to be really active in Instagram. This is a particular user named Yukiko Sakamura. Please check out the link. I will post it in the description of the video. She creates visualization of things that happen in her life daily. And I've picked this one that shows where her time goes in a week. Suppose this was also my life. What have I explored? Well, my exploration shows why I don't have 6-pack abs because I don't exercise as much as bodybuilders do. This is an assumption. If I don't feel too grumpy during the week, maybe the 55 hours of sleep is doing me good. If my friends say they don't feel my presence in our friendship, despite me giving them 20 hours of my week, then maybe I need to spend 30 hours of my week with them. When you're using data visualization to make sense of information so you may arrive at an action for yourself or for your team, you are doing it in an exploratory manner. Exploratory data visualization. What's the other one? The second goal of data visualization is explanatory. Explain. That is, you are presenting data so you can influence and persuade. Kindly pause this video and check out humanprogress.org. Specifically, I've handpicked this graph entitled Top 10 Cancers by Rates of New Cancer Cases. Instead of an hour-long talk convincing people to support breast cancer research, because out of the 10 top cancers, it's the most prevalent among citizens of the world, blah, 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 I may just show them this visualization and say, please support female breast cancer research. Thank you. This actually takes us to the discussion of what makes for a good type of visualization. So, what makes visualization effective? Number one, speed of information transfer. Just like the breast cancer example, when you create a visualization, continually ask yourself, is my visualization faster understood when written or spoken? Because if it is, then the visualization might not be needed at all. Going back to our battery visualization example, some phones make you opt for text to show how much battery you have left, and that's for good reason. Both visualization and text form may be understood swiftly. This is also the reason why data visualization is becoming popular in the era of big data. The big data is just too big to communicate using words. So the images, the crunching of the numbers, turning them to images, apparently they help. Number two is ability to stand alone. Remember that your data visualization is like your baby who will grow into a fine young man or lady, and you cannot take care of it anymore. It must learn how to stand on its own and defend itself. You won't always be physically there to explain your data visualization, and as a standard, if you need to explain the context of your data at all, then your data visualization fails its purpose. Number two is ability to stand alone. It must be able to explain itself. Number three, audience fit. I'm trying to find the link to the study. If I find the link, I will link it in the description. But there is a game developed for India, or there are researchers in India that developed a game for kids so that they would learn elementary mathematics. And the nature of the game is similar to Super Mario Brothers, where the protagonist player must collect coins in order to progress in the game. During their initial approval testing, they were shocked to see that the approval ratings were very low. When they did focus group discussion, they discovered that for the Indian culture, collecting coins or things of material possession is frowned upon as a measure of progress or success. The team later on replaced the coins in the game with corn to align with India's agricultural context, which is the same schema in the heads of their target audiences. Be sure to do the same with your data visualizations. So, we now come to visualizations that survive the test of time. As we have seen from our Dear Data exercise, we can go crazy with how we present our visualizations. However, here are some visualization standards that have somehow survived the test of time. You might want to consider them when brainstorming possible visualizations for the data that you have or will have. So this is the chart. Exploring these charts is left as an exercise. In a moment, we'll try looking at an example to hopefully show you that generating the charts you see on the screen may be done with just one command. The challenge really is data prep, or cleaning the data so that it is in a form that the command to generate the graph could understand. But for now, let's wrap up this video so we can proceed to coding. There is something called the International Business Communication Standards, IBCS, that suggests an acronym. The acronym is SUCCESS, to check whether your data visualization is proper. S stands for say a clear message. Ideally, a visualization should communicate one clear idea and one clear idea only. If you're communicating a lot, then you're overloading your audience. The whole point of a visualization is for speedy transfer of information, as we have discussed, and that is facilitated if you try to focus on communicating one clear message only. U stands for Unified Semantic Notation, and this is just a fancy way of saying if you be consistent with what you're using as design. If you use the color red to denote anger, then use the color red to denote similar emotions if those similar emotions can be found in your visualization. C is for condense. Can your visualization stand alone or does it offer context on its own? Condense your visualization so that they can fend for itself. It can fend for itself. E is for express. Think of your audience and what expressions you think will work for them. And this is something that I would want to highlight because you did your Dear Data exercise. Did you ever think of creating a visualization based on what me and your Sir Zenon could understand? Because if we were your audience, then that should have been part of your consideration. Or if the class is your audience, did you take into consideration what could be something that the class, the schema of the class, their prior knowledge can already hook onto when I'm designing my visualizations? Second S is for simplify, or to break simplicity if needed. Be a minimalist or a maximalist depending on what works for your message. And this is something that will be clearer the more you practice creating visualizations for your data. And the last S is for structure. Whatever design you come up with, whatever strategy you choose to take, the most important thing about the visualization is it communicates a story. Try to design your visualization so that a coherent story is transferred to the user. You're essentially creating a novel, but in image form. And that poses its own challenges, as we will see in the next video, where we'll now start coding. So, that's it for this video. I'll see you in the next one for the software that you need to install and the code that you need to work with. Thank you.